Imagine a time, before stars, before planets, before even the concept of up or down existed. Everything that is was compressed into a space smaller than the tip of your finger, impossibly hot, unimaginably dense. Then around 13.8 billion years ago, something incredible happened. The Big Bang. It wasn't an explosion in space, but an explosion of space itself. Everything began to expand rapidly, furiously, like a balloon inflating faster than you could ever imagine. In those first fleeting moments, the universe was a chaotic soup of tiny particles, the fundamental building blocks of everything. It was too hot for anything solid to form, but as it swelled, it cooled, and eventually, the very first lightest elements were forged: hydrogen and helium. These are the true ancients of the universe, the original ingredients. About 380,000 years after that initial burst, the universe cooled enough for these particles to settle down and form the very first simple atoms. This was a monumental moment. Light, which had been trapped and scattered, was suddenly free to travel. That ancient glow is still around us today, a faint whisper from the beginning called the cosmic microwave background, the universe's oldest baby picture. After that initial flash, the universe went through its dark ages. No stars shone yet, just vast clouds of hydrogen and helium gas drifting through the expanding void. But gravity, that invisible sculptor, was at work. Over hundreds of millions of years, it pulled these gas clouds together. Denser clumps grew denser, hotter, and around 100 to 200 million years after the Big Bang, the pressure and heat in the centers of these colossal gas clouds became so intense that fusion ignited. The very first stars were born. These were titans, hundreds of times bigger than our sun, burning incredibly bright and living short, furious lives. And when they died, they did so in spectacular, universe-shaking explosions called supernovas. These supernovas were the universe's first factories. They cooked up and scattered all the heavier elements, the carbon for our bodies, the oxygen we breathe, the iron in our blood, the silicon for our technology. Without these cosmic deaths, there would be no us. As more stars formed, they began to cluster together, swirling into magnificent structures we call galaxies. Our own galaxy, the Milky Way, slowly began to take shape within this grand cosmic dance. Fast forward billions of years. Our corner of the Milky Way was still just a massive cloud of gas and dust, a stellar nursery enriched with all those heavy elements from countless supernovas. And around 4.6 billion years ago, something disturbed this cloud, perhaps the shock wave from a nearby dying star. It began to collapse inward, spinning faster and faster, flattening into a vast, rotating disk, like a cosmic pancake. Most of the material gathered at the center, growing hotter and denser, until it ignited, and our sun was born, a steady furnace in the heart of our new solar system. In the swirling disk around the young sun, tiny dust grains began to bump into each other. They stuck, then they grew, from tiny specks to pebbles, to rocks, to boulders, to mini planets called planetesimals. This was like cosmic Lego, building itself through countless collisions. Closer to the fiery sun, only rocky and metallic materials could survive the heat, forming our inner rocky worlds: Mercury, Venus, Earth, and Mars. Further out, where it was colder, lighter elements and ices could condense, forming the gas and ice giants like Jupiter and Saturn. Dance. And so, our own home, Earth, was born, around 4.5 billion years ago. In its infancy, it was a hellish place, a glowing, molten ball, constantly bombarded by leftover debris from the solar system's formation. Imagine a planet-sized forge, incredibly hot, with volcanoes spewing gases into a toxic atmosphere and giant asteroids raining down. As it cooled, the heavier elements like iron sank to the center, forming our planet's core, while lighter rocky materials floated to the surface, creating the beginnings of our crust. This process, called differentiation, gave Earth its layered structure. Then another monumental event occurred. Around 4.5 billion years ago, a Mars-sized planet, sometimes called Theia, is thought to have slammed into the early Earth. This wasn't just a bump, it was a cosmic impact of unimaginable scale. It blasted enormous amounts of molten rock and debris into orbit around Earth. That ejected material then came together, coalescing under its own gravity to form our loyal companion, the Moon. The Moon's creation likely tilted Earth on its axis, giving us our seasons, and its gravitational pull helps stabilize our climate, making it just right for life. After the Moon's formation, Earth slowly, painstakingly began to cool. Over hundreds of millions of years, the steam from its volcanic eruptions condensed in the atmosphere. And then, the rain began. Imagine rain not for hours or days or even years, but for millions of years, falling onto the cooling surface. These endless deluges filled the deep basins and depressions on Earth's surface, forming the first oceans. These early oceans were hot and acidic, filled with dissolved minerals from the volcanic rocks. By around 3.8 billion years ago, the Earth had transformed. It was still volcanically active, still undergoing immense geological shifts, but it had a stable crust and, crucially, vast liquid oceans. The stage was set. The raw materials were there, and in those warm, chemical-rich waters, the impossible would soon happen, the spark of life itself. This story sets the foundation for your narrative. It's about cosmic violence, incredible timescales, and the gradual emergence of the conditions necessary for life.